Okay, 9.3 rotations and 9.4 compositions of isometries. Okay, a rotation of x degrees about a point Q, called the center of rotation, is a transformation with these two properties. The image of Q itself, okay, now Q itself, this is the center of rotation, that is Q prime equals Q. So whatever the center of rotation is, that's going to end up, the pre-image is going to be right on itself, okay? For any other point V, QV prime equals QV, and the measure of angle VQV prime is equal to x degrees. Okay? The number of degrees a figure rotates is the angle of rotation. A rotation about a point is a rigid motion. Okay, that means it preserves distance and it preserves angle measure. You write x degree rotation of triangle UVW about point Q as r sub x degrees comma Q of triangle UVW equals triangle U prime V prime W prime, and that once again is a notation thing. All right. A few common rotations for you guys to notice. When a figure is rotated 90 degrees, 180 degrees, or 270 degrees about the origin O in a coordinate plane, you can use the following rules, okay? And these are pretty self-explanatory. I'll just let you guys take a look at them, okay? All right, let's do an example. Construct the 90-degree rotation of square ABCD about point P. The best way to do this is to pick a point here. So in this case, I'm going to take point A, and I'm going to draw a line from A to my point P. Okay? Now, if I want to make a 90-degree rotation, I need to make a 90-degree angle. I went ahead and did that. Here's my 90-degree angle. So my A prime needs to be over here. Okay? Okay, I did the same thing for B. It looks like B prime is going to be right there. Okay. C to P is going to be a horizontal line, so I'm just going to draw a vertical line. So here's my C prime. And you can kind of see from these 3 points, let me pick a different color. How about blue? You can kind of see from these 3 points where D prime is going to be, because it has to maintain the same shape. Whoops. So here's my figure. Looks like it's going to be this one here. Okay? All right. The composition of 2 or more isometries is an isometry. Okay, reflections across parallel lines. A composition of reflections across 2 parallel lines is a translation. So if you look at this, if I was to reflect this triangle across this line, as you can see, triangle A prime, B prime, C prime is reflected. It's symmetrical across line L. And if I reflect it again across line M, now the triangle is in the same position that it was in at the beginning. Okay, so if I reflect it twice across 2 parallel lines, it's really just a translation. It's really just the triangle shifted a certain direction, each point the same distance. Okay, you can write this composition as R sub M, and then this little circle, R sub L, of triangle ABC. I'm going to write a little something over here. You don't have to write this part, but if you guys remember back in algebra when you would learn composite functions, you would have f of g, and this was another way of writing f of g of x. Oops. Hopefully you guys remember that. If not, that's okay. That's when you would take one function and plug it in for x in another function. Okay? The same thing is going on here. This is a composition of transformations. Once again, you don't have to write all that. You can if you want, if it helps you. Okay. Also, A prime, B prime, and C prime are all perpendicular lines to L and M. So if I was to draw a line for, or double prime, sorry, A double prime, B double prime, C double prime. So if I was to take a line and draw this from A to A double prime, that line is going to be perpendicular to the two parallel lines. Same thing with B double prime, and C double prime. All right, let's see here. Okay, a composition of reflections across two intersecting lines is a rotation. So as you can see, if you take triangle ABC and you reflect it across line L, and then you reflect it again across line M, now you have a regular rotation. This is just rotated over here, okay? You can write this composition as R sub M little circle R sub L of triangle ABC, or R sub M of R sub L of triangle ABC. And this would equal, both of them actually equal triangle A double prime, B double prime, C double prime. The figure is rotated about the point where the two lines intersect. So in this case Q, so if it's reflected across two intersecting lines, the center of rotation is the point where the two lines intersect. Okay, let's do an example. Find the image of the letter for reflection first across line L and then across line M. Is the resulting transformation a translation or a rotation? For a translation, describe the direction and distance. For a rotation, tell the center of rotation and the angle of rotation. All right, so this is what's going on. It's reflected across line L and then reflected across line M. Now, if you remember, anytime you have something reflected across two parallel lines, it's going to be a translation. That means it's going to be in the same position, just in a different place. So as you can see, these ones, A and C, T is rotated. The only one where T is not rotated is B. So this is a translation. Okay, which of the following describes the transformation? We know it's a translation, so it's one of these two. It is a translation down and to the right. Well, that's true. The distance of the translation is the distance between L and M. Well, that's not true. The distance from, let's say, this point here to this point here is a lot longer than these two. It's about double that. So it is a translation down to the right. The distance of the translation is twice the distance between L and M. That's the correct one. Okay, what transformation maps the black triangle onto the blue triangle? Now I realize on your paper you can't tell which one's black or blue, so you can label the top one, just label it, this one's black, and this one's blue. Okay? As you can see, this is going to be some kind of reflection. Let's count the spaces between this point and this point. Got 1, 2, 3, 4, 5, 6, 7. 7 spaces. So halfway in between 7 would be 3.5. Okay, so if I count 3.5 spaces, I'm going to end up at, it's hard to tell, but this is y equals -1. Or sorry, not -1, -1/2. Okay, so this is the line of reflection. Let's go down here. Which transformation maps the black triangle onto the blue triangle? Now you remember, the little r means rotation, and the big R means reflection. This is reflected across the line y equals -1/2. Voila. Okay, graph the glide reflection image of triangle ABC. Okay, so we're graphing the glide reflection of this triangle. The first isometry is a reflection across the line y equals 0. Y equals 0 is this line here. So I'm going to reflect this triangle across this line. There we go. I've got A prime, B prime, C prime. The second isometry is a translation of -2, 0. That means that x is going to go 2 this way, and y doesn't move at all. So it's just shifting to the left 2 spaces. Pick a different color. So 2 spaces from here is here, 2 spaces from here is here, 2 spaces from here is here. So here would be, sorry for the not so straight lines, here would be my new drawing. So the red triangle is what we're looking for. Alright, so let's take a look. It's definitely going to be one of these two. Now, it's kind of hard to tell because you can't blow it up, but if you were able to expand this, when you do this problem on Math Excel, you'll be able to blow up the diagrams and count the little spaces. It's actually going to be this one here. Okay, it's hard to tell because you can't really count the spaces because it's super tiny, but when you do this problem in your homework, you'll be able to expand the diagrams. All right, and that's all the notes for today.